Hello everyone, welcome to the Learning Cubicle. Today we will be learning to draw the image formation in case of concave mirror. That is, we will be drawing the geometric images for various positions of the object. Like in the previous class, we have done the same for a convex mirror for two different positions of the object. One, the object is at infinity. Two, the object is anywhere between infinity and pole. In the same way, we have for concave mirror 6 different positions of the object, and we will be following the same rules and we will be following the same procedure of drawing the images in case of concave mirror as well. Right, so we will be first drawing the mirror using a compass with a very large radius. Okay, and we have discussed the reason why we should do that. Right, so first let us draw the concave mirror using the compass. So first we will mark the center of curvature, okay, and then we will place the needle of the compass over here, and then we will draw the mirror. So that's the mirror, and now we will take the scale and then we will join the center of curvature to the mirror. We will also extend it behind the mirror. And even this side. We will now mark the center of curvature. We will now mark the pole over here on the mirror, and the midpoint of CP is focus. That's over here. There's the focus. Now, since this is a concave mirror, the outer side is polished and the hollow side is reflecting. Now, the first position of the object is at infinity. So the rays of light come parallel to the principal axis and also parallel to one another. So we will be drawing rays of light parallel to the principal axis and are parallel to one another as well. Now, according to the rule, any ray of light which first passes parallel to the principal axis after reflection actually passes through principal focus, because this is a concave mirror. So we will pass all these rays through focus. This is the point of incidence, this is another, and this is another. This is how the image formation takes place when the object is at infinity, right? So now we will learn the characteristics of the image formed for this position of the object, that is when the object is at infinity. Right. So when the object is at infinity, as you can see here, the rays of light are actually meeting at a point. So the image formed will be real, and a real image is always inverted. So when we have learned the nature of the image real, the rays of light after reflection actually meet at a point. So we got the real image, and real image is always inverted. And coming to the size of the image, it is barely visible over there. So it's a tiny dot. So the image is diminished to a point. So that's the size of the image, diminished to the point. Now where is the position or location of the image? It's formed at focus. So the image is formed at focus in front of the mirror. For convex mirror it was behind the mirror, and for concave mirror it is formed in front of the mirror. So that is the characteristics of the image formed when the object is at infinity. Now we will move on to the second position of the object. Right, now the second position of the object, now we will move it a bit closer to the mirror, that is we will place it beyond C. That means it is at a finite distance, it is reasonably closer to the mirror, right? So somewhere over here we will place the object, and as mentioned earlier, when the object comes close to the mirror, we will show the object, but when it is at infinity, we don't show it. So I am showing the object now. With a head and a tail, and one ray I will draw parallel to the principal axis. That is this one. This is its point of incidence. And another ray I will draw through the focus, or you can even draw through center of curvature, any which way, no problem. Okay, let us draw the ray through the principal focus. This is the second ray, and for these two rays, when we apply the rules, any ray of light which first passes parallel to the principal axis after reflection goes through focus. And any ray of light which first passes through focus goes parallel to the principal axis. So this is one reflected ray and this is another reflected ray, and both of them are meeting over here, and this is where the image is formed. Since the rays of light are coming from the head, so here the head is formed. So this is how you show the image formation in case of concave mirror when the object is beyond C. Now we shall learn the characteristics of the image formed. Right. So as I said, the object is beyond C. The rays of light are actually meeting over here, you can see. So the image is again real and inverted. And you can see it is not diminished to a point, but it is diminished, small size. So it is just diminished in size. And the image is formed here between C and F. you can see. So the position or location of the image is between C and F. So these are the characteristics of the image formed by the concave mirror when the object is beyond C. Now let's move to the next position, the third position of the object, that is when the object is at C. Right, so now we will place the object at C. And we will draw one ray parallel to the principal axis. And the other ray through focus. So the ray of light which passes parallel to the principal axis after reflection goes through focus. So that's the first rule we have learnt. And the second ray which passes through focus goes parallel to the principal axis. So these rays of light actually meet at this point. So this is where the image is formed. As you can see there. Okay. So when the rays of light are coming from the object which is placed at center of curvature, the image is also formed at center of curvature. Now we shall learn the characteristics of the image formed when the object is at center of curvature. So when the object is at center of curvature, the rays of light are actually meeting after reflection. So the image will be a real and inverted image again. And if you look at the size of the image, it is exactly the same size as the object. So image is same size as object. And where is it formed? It's formed exactly at C. At C. Okay. So these are the characteristics of the image formed when an object is placed at center of curvature in front of a concave mirror. Right. The next position is the object is placed between center of curvature and focus. So we will be placing the object somewhere over here between center of curvature and focus. And we will draw rays from the object, one ray as usual parallel to the principal axis. And this time the second ray will be drawn in such a way that it hits the mirror at an angle of 90 degrees. So any ray of light which hits the mirror at an angle of 90 degrees would obviously go through center of curvature. And we all know the ray which goes parallel to the principal axis after reflection goes through focus. And as you can see, this is where the rays of light are actually meeting. And since the rays of light are coming from the head, so the head is formed over here. And that's how the image is formed. Right? Now we shall study the characteristics of the image formed in this situation. Yes, as you can see in the diagram, the rays of light after reflection are actually meeting at this point. So again, even in this case, the image is real and inverted. And look at the size of the image when compared to the size of the object. It's too big. So we can say that the image formed over here is enlarged. Okay. Now where is the image formed? It is formed beyond C. It's formed beyond C. So the image is formed beyond C, but not at infinity. It is at a finite distance. So image is formed beyond C, but not at infinity. So we shall now move to the next position of the object, which is obviously the principal focus. Right, the next position of the object is we will place the object at focus. Now we are going to draw the same rays what we have drawn in the previous diagram, that is one ray parallel to the principal axis and another ray hitting the mirror at an angle of 90 degrees. Now this ray which is going parallel to the principal axis after reflection goes through focus. So these rays of light cannot meet anywhere at a finite distance. So the rays of light tend to go to the infinity, right, which is a very far distance from the object. So now let us study the characteristics of the image formed in this situation. Right, so the characteristics of the image formed in this situation, as I said, the rays of light are going to meet at an infinite distance. So even here the image is real and inverted. And the rays of light were meeting earlier in the previous situation at a finite distance and we got the image enlarged. But in this situation, as I said, the rays of light are going to meet at a very large distance. So the image formed in this situation would be highly enlarged. Highly enlarged. And where is the image formed? The image is formed at infinity. At infinity. What I want you to observe over here is that when we place the object at infinity, the image was formed at focus. And when we place the object at focus, the image is formed at infinity. So what you can understand from this is that As the object is moving closer to the mirror, the image is moving away from the mirror. Okay, it happens in every other situation. You can observe that, study these characteristics. So as the object comes closer to the mirror, the image moves farther from the mirror. Now let's move on to the next situation, that is when the object is placed between focus and pole. Right, the next position, and in fact the last position of the object in front of concave mirror, is object between focus and pole. And this is one case in the image formation where the rays of light after reflection do not actually meet, right? And here I am going to place the object between focus and pole, somewhere over here. Now here I am going to draw two rays, one ray hitting the pole and another ray hitting the mirror at an angle of 90 degrees. And in this case, like all the other cases, we will not be drawing a ray parallel to the principal axis. The reason being, I'll be explaining you while I am constructing the diagram. Okay. So this is one ray I have drawn to the pole, and the other ray I am going to draw perpendicular to the mirror, which obviously goes through center of curvature after reflection. So this is one reflected ray. Now what about this one? Let us measure the angle. So as you can see, when I put the protractor, I cannot see the object over here. So in order to get an approximation, I am placing the dot just above it over here somewhere. And I am getting that angle approximately 42 degrees, right? So I will be marking the same angle even below 42 degrees. I marked it over there. Now I am going to join this to that point, that is a pole, because angle of incidence is equal to angle of reflection, and I have told you this is the fourth rule. When a ray of light hits the pole, it gets reflected at the same angle because principal axis acts as a normal over here. So this is one reflected ray and this is the other reflected ray. These both rays can never actually meet, but they appear to diverge from a point which is behind the mirror. Now let's see where are they diverging from. Since these are not the actual rays, I am drawing a dotted line over here. Okay. Now this one as well, we shall extend backwards. So they are appearing to diverge from this point over here. Okay. So at this point, since the rays of light are coming from the head, we have the head forming over here. And since this is obtained from the rays of light which are not actually meeting but appearing to diverge from a point, so we call this as a virtual image. And virtual image we cannot draw with a thick line like how we have drawn the real image. It is also drawn with a dotted line. You can see there. Now coming to the aspect, I was saying that we cannot draw a ray of light parallel to the principal axis in this situation. Now why? When we draw a ray of light parallel to the principal axis, it comes like this, okay, this way. Now after reflection, this ray of light should go through focus, means this way it should come. That means the ray of light should pass through the object, which is practically not possible. If we take an object which is opaque, the ray of light cannot pass through the object. So for this situation, we do not include the ray of light coming parallel to the principal axis. Now we will move on to the characteristics of the image formed in this situation. Right, now coming to the characteristics of the image formed when the object is between focus and pole. As you can see here, the rays of light are not actually meeting, but they are appearing to diverge from a point. So the rays of light are not actually meeting. So this is one situation in concave mirror. The image formed is virtual, and a virtual image is always erect. Right? Now coming to the size of the image. This is the size of the object and this is the size of the image. So we can see here the image size is enlarged. And coming to the position or location of the image is formed behind the mirror. It is formed behind the mirror. So we simply write here, image is formed behind the mirror, because virtual images are always formed behind the mirror, whether it is plane mirror or convex mirror or this situation of the object in case of concave mirror. Virtual image is formed which is always behind the mirror. Right? With that, we are done with the image formation in case of concave mirror. Thank you.